Hello everyone. Thank you for being here. I'm Urmila Raju. I'm a senior solution architect with AWS. Today we are going to talk about AWS Serverless Application Model or the AWS SAM. This is going to help you with your development and deployment of modern serverless and cloud native application. Let's get started. SAM is an open source developer tool that simplifies and improves the experience of building and running serverless applications on AWS. It's going to streamline your serverless development cycle and help you to quickly and efficiently take an idea into production. So first of all, it says that SAM is for modern cloud native apps. Right? How do you define a modern cloud native app? Through the modern architectural patterns like event-driven architecture, microservices, and use serverless services wherever possible to increase the operational efficiency and have developer agility, that is, ability to deploy fast in an automated way and have abstractions wherever possible to remove the undifferentiated redundant work. And of course, on top of that, have the necessary guardrails and use standardized services so that you have your governance still in place along with speed. And then this is another one that is to use purpose-built databases and data sources that is right for your application. So these are common principles of a modern cloud native app. And today's focus is mainly going to be in these three areas, that is serverless, developer agility, and how do you maintain governance, that is DevOps plus serverless. And see how can we build and deploy serverless apps with speed. So the first thing, before even going to think about which tool is right for you, the main thing to know is your cloud operating model. That is, how do you manage and run cloud today? Is it ready for your modern apps? I want to show you some operational model frameworks. So we'll start from the left, that is like traditional operations. So you can have a look and see where your organization fits in this operation model. So for a traditional, like a monolith application, like a front-end, middleware, and back-end database, usually there will be like different teams like application engineering, application operations. Same way, if you are deploying it in cloud, there will be cloud platform engineering and operations team. And then we have distributed DevOps or decentralized DevOps. So both of these are DevOps models. It's like how it differs is, what is the level of autonomy you give to your application engineering team to build and run their own components? And how much of the control and governance you have with the cloud platform engineering? So usually organizations start with distributed DevOps and move towards decentralized DevOps. And for building modern applications, using these kind of DevOps frameworks is really needed. So you need frameworks to deploy code and infrastructure to your accounts, that is AWS accounts, to support an application runtime, operations, and optimization. So when you come to serverless apps, how do you do that? And what are the challenges? The thing is, like code and the infrastructure, though there is not any real infrastructure, you still have to like create your serverless services, right? And that with the code are tightly coupled. Examples being these services, and there can be many more examples, but the key ones here, that you create a Lambda function and your runtime and the code is within that. And if when you use Event Bridge, you provision an event bus and your business rules of which sources come into the bridge and which targets you're going to reach out to stays within the Event Bridge rules. Similar way, all the business function workflow is going to remain within step functions. So in that case, who takes the responsibility of what? And how do you choose the right infrastructure as tool that is going to help you with building such a serverless modern application? So I'm going to show you some ISC tools because it's not just, I'm going to say that it's all can be done in AWS SAM because it depends on various factors of what is right for your organization. So we have AWS native options like AWS CloudFormation, which is in the YAML format, and all the features and services to deploy them are available, constructs are available within AWS CloudFormation. And AWS SAM, which is the focus of today, is built on CloudFormation, but it has various most powerful features and constructs, which is going to help you specifically with serverless resources and applications. And also a higher level tool or a construct is the AWS Cloud Development Kit. So this is based on writing the infrastructure as code in programming languages. For example, if your app team, so when we discussed on distributed decentralized DevOps, where the application management team is going to have most of the ownership on the code. In that case, you can use, let's say your organization is fully on a Python stack, then you can write your infrastructure as code in Python and use Cloud Development Kit for that. Another option is the open source tools, like the serverless framework or the Terraform. So these tools are like platform agnostic, so you can use it on-prem, AWS, or on other cloud providers as well. So if you have been like using such tools, let's say Terraform, and we want to continue to use that in AWS, you can very well do that. But one thing to highlight here is, so whenever there is new features and services coming in, so it gets available in CloudFormation first. And then, since SAM is built on CloudFormation, immediately you can adapt it into the same SAM framework. But it will take a few time for those frameworks or new features and services to be available and supported by these open source tools. So that is the caveat here. So now with that, we'll see what are the, I'm going to highlight on where SAM is going to be useful. Because SAM, as I mentioned, is not just IAC. There are many more things that we are going to see of how you use SAM. So we will focus on that for the rest of the session. So first, what I want to show you is a practical guide to using SAM, using a serverless GenAI app example. So first, I will show you a demo of that application so that we know that what we are working on. Then we will see the architecture of it and then see how you build that application in parts using AWS SAM. So why I've chosen a GenAI application is, so it's when we say serverless, it's not just usual services like API Gateway, Lambda, DynamoDB, etc. So I want to showcase how you can use the rest of the serverless ecosystem within AWS and bring it into SAM and build applications very quickly. So let's get into that. So this is a very simple GenAI application. So what we're going to do is, this is like for an event, if participants are coming in or the attendees. So here I've taken our Conf42 Cloud Native 2025 as an example. So attendees, after attending the session, will give their name and it will select any of the sessions that they attended and submit it. So when they submit, they will get a session summary about the session that they attended. And also, they will be allowed to do some feedback on that session. So let's do that. I'm giving my name here. Let's say in this dropdown, you have the full list of all the sessions. So I've just given 4 examples, and I'm going to choose my session as the example and submit it. So once it submits, it goes to the backend. We will see the architecture next. But for now, let's just see the demo. So it's waiting on a response. So it is going back to actually a GenAI model to feed the session name, and it is getting a session summary based on the abstract of the session. So if you see in the Conf42 page, there is a session abstract. So I have loaded that into a table. So the system will fetch that abstract and create this summary based on that abstract. So that's the first part. So we are using GenAI for that. And the next part is we will ask them to rate the session. It's my session, so I'm just going to say it's an excellent session and give some text feedback, like useful session to start with apps, something like that, and submit the feedback. So now it's again waiting on a response. So what we are doing is, based on that feedback, we are going to create a thank you note for that participant. So it says, "Dear Urmila, thank you for attending the session," which is picking up the session name here. And it does a sentiment analysis on what feedback that you have given as well. And it says, "We are glad you found the session helpful and we are delighted to invite you for future events." Yes, something like that. So this one is also GenAI generated. So you see 2 GenAI generated text generation example here. So the application works in such a way that if you want to generate new content again for another session, you can click on this button and do that, or just finish to complete that. So that's a quick example of this architecture. So we'll see the actual architecture behind it. So just one thing to note here is what's happening is you're filling in some details and you're sending it to the backend. And from the GenAI application perspective, whatever you give here, that is the name of the session and your feedback here, all are like user prompts that you give to the GenAI system behind. And using that, there is a GenAI response that you receive back. So that's the demo. So now we will go back and see the architecture. So this is the full architecture of this app. Don't worry, we are not going to build the whole thing using SAM within this session. I'll take you part by part here. So there are though this is a full one application, you can do it in a very modular way. And in an actual organization, there could be multiple teams who collaborate with each other to build such an application. For example, there could be an integration services team whose responsibility is to bring the data from your, let's say from your front end to your middleware, and then at the same time, take the data from your backend back to your front end. So in this case, what's happening here is you have an API gateway through which you get so if you remember the demo, whatever you type in the front end is coming to the API gateway and going to a Lambda and then it gets published as an events in an event bridge. This is a fully event-driven architecture. Whatever response that you see back in the front end is not going in the same API gateway call. So the API gateway call is just to publish the events. So if you see in the backend, from again the results are published into the event bridge, which goes to the front end through asynchronous messaging. And there is I'm not going to explain each of the services here, not in the scope of the session, but you can use services like AWS IT Core to send asynchronous messaging to the front end. So that's what is used in this design. And let's say that team A is they take the responsibility of doing this type of integrations for receiving the events and also sending back the events to the front end. And then there can be a business application team who manages the actual business logic of this application. So in this demo, you saw that there was two parts. One is first it generated a summary and then it created a thanks note. So both of these events gets evaluated in an event bridge rules. Actually, there are like two rules. I've just put like one rule in this diagram. And then it goes to a step function. So part of what's happening in the step functions for now. But this why I've shown this other flow is, so this application, though we just saw a text summary, there could be other new features which can be added in a very modular way. So that which can be treated as another event, and it goes through another rule and goes to another like GenAI model to create an image, maybe in that case. So we're not going to see that part in the session, but this is just to show you how an event-driven architecture can modularly grow. And then there can be a GenAI team who actually suggests on which model is best for you and provides the API information to access that and all that. And maybe there can be a front-end team as well who is managing the front-end code. So now let's look at how to use SAM. And we will start in a very simple way of just focusing on this integration services team A, and then look at these three parts alone. That is receiving the events from the front end through API gateway Lambda and then publish it into an event bridge. And how do we use SAM for that? So SAM has two parts. One is the transformation templates, which is the actual similar to CloudFormation template, the YAML template, which can be used as the infrastructure as code. And next is the SAM CLI, which is the used for like local development and testing, building, packaging. And also from there, you can directly deploy, create pipelines and lots more. So we will see an example of all of this across the development cycle using this GenAI application as an example. So as I said, it's built on top of CloudFormation, so it's still YAML. So the SAM template as well is YAML. But if you look at this transform statement at the top, so when you create a SAM template, it gets converted into a CloudFormation template internally when you build it, and then you deploy it. So finally, when you are deploying it, it is going to get deployed as a CloudFormation stack behind the scenes. So this is just an example of how a SAM template looks like. So the notation for using the SAM construct is AWS Serverless, and if it is Lambda, it's called function, and we have nearly 9 resource types, which we will see in the next slide. And also pay attention to this same row. So you can associate like managed policies. So these are the another advantage. So here this Lambda function has to read a DynamoDB table. So you just add the policy and give the table name as the reference. So all this ref, all are like usual CloudFormation notations that you will use. I will be using it all along in the session, assuming that you have some idea on how CloudFormation works. Yeah. So this, what is the advantage of using this is, it is going to help you define fine-grained policies. That is the permission of this Lambda is going to be restricted to just this table and just for the read. So that is built in automatically when you use this kind of managed policy. And then when you use events, it is going to attach a API gateway. And this one is for DynamoDB table. So just with this code, a few lines of code, you are able to create a Lambda function, a DynamoDB table, an API gateway, and also the IAM role for the Lambda function to access DynamoDB table. So that's how these kind of high-level serverless construct. So we have this available for 9 resource type, which you can use, and then reduce the number of lines of code that you actually write for infrastructure as code. And to make that into a bigger CloudFormation template, SAM takes care of it. And yeah, so this is the IAM policies, managed policies that I told. There are 75 plus policies available. So you can so this is the link. So have a look at that before defining your own policies. See that if any of these can be just leveraged without having you to write in-depth policies. And yeah, so here as events, because Lambda is invoked. How does Lambda invoke? It's invoked only at an event. So the event can be API gateway, as in this example, but there can be other events which is triggering Lambda. So in SAM, there are 19 plus function events that is supported. So example, if there is a file arriving in S3, that could be a trigger to trigger a Lambda function. or a DynamoDB stream event, that is and a record being updated, deleted, etc. And so all of this can be leveraged in SAM. So I kept mentioning that SAM can be used across the development cycle, and it's not just for building infrastructure, right? So as you can see, these are the various SAM CLI commands that you can use, and it is spread across the development cycle. So whether you are a person of an application developer or you are a DevOps person, as we go along, you can see where you can use each of these CLI constructs, and for your own persona and the type of job you do and making the application live. So let's first start from the SAM init and then go along each of it. For the SAM init, we are going to look at just this area, which is the API gateway and Lambda, and go from there. So this is my IDE that I use. You can use any IDE of your own, like VS Code, or anything that you prefer, which can have like code and terminal and ability to access your local files. So in here, there are already some demo applications, but I'm going to start one saying SAM init. So all of the SAM CLI. So this IDE, I've installed AWS CLI, SAM CLI, and Docker as well as a prerequisite. Why Docker? We'll see. So when we do SAM init, it's going to ask you, give some quick start templates and custom templates. So if you already have a template, you can bring it into that. But we'll do a quick start template, and it has all this like serverless API, standalone function, and we'll just do this hello world example for now. And what are the runtimes that you want to use? I'm going to give n not plus Python 3.13 to show you all of the other things that is available. So you can choose anything that you need. My IDE is at Python 3.9, so I'm just going to use that. And we are not doing image type, we're doing normal zip. And all this tracing and monitoring, I'm not going to enable it for now. And then you give a project name for this. So we're doing, if you remember, we are doing team A, B, and C, right? So this is for team A. So team A app 1, I will name it like that. So now if you see team A app 1, it has created a folder structure with various subfolders. And the main thing is this template.yaml file, which is the SAM template itself. Yeah. So I will use a terminal below from now on. I'll close this. We will go into our app 1 folder. And if you see, we have already got the resources, which is the function, this is a Lambda function, and the runtime that you chose. And the events, it is triggered by an API. So everything is available already. And this outpost section is to give some idea on the resources created when your CloudFormation stack gets deployed. So when you finally have the resources deployed, when you go to the output sections of the CloudFormation stack, you will see the API endpoint, function endpoint, and the function IAM role. For now, we are going to just comment it out and focus on here. If you see, we have the hello world and app.lambda handler. So that is the template. And then for each of the function that you create, there is a subfolder in which there is an requirements.txt file and the actual app code here. So we chose Python, so the code is in Python. So there is some example. So I have a code that is needed for sending the necessary information for us. So I'm going to copy paste that code into this function, and then we'll see what the code has got. So this code, if you see, what does it say? Indentation is not proper. Yeah. Okay. So this is a simple Lambda function where it is going to get the event from the API gateway and publish it into an event bridge. So that's what it is saying. And the input parameters that you have here. So once you put it in Lambda, the both or three, it's all like automatically imported. For local testing, you can put that in your requirements file. So this was the default one. We don't need a request package. We need both the three. So I'll put that here and save that and close this. And for the rest of the details, so if you see, it is taking the event and writing that event in a different format. So it is giving a source column, detail type, and the actual detail that is coming in the event bridge. We will see what that detail is. And then it is giving a event bus name. So I have an event bus already created in my AWS account. So in the interest of time, I'm not going to show the IAC or some template for the event bus as well. I used this for a previous event. That's why the name is Cloud Dublin. So the event bus, this is the event bus if you look in the console. And within the event bus, we have various rules to send it to various targets based on what the event type is. So we will see into that rules in a while. Coming back to the console. So you have your code ready now. So the next step is, before you go and directly deploy it, SAM provides you the ability to do a local invoke of this Lambda function to see if the code is right you have built it before getting into deployment. So that we will see as the next step. Okay, so the next piece that we are going to see is about the SAM local. That is, how do you locally test your serverless resources before getting it into deployment. For Lambda, as I mentioned, you need to have the events from a particular service. So you can simulate events using SAM local from each of the services that you see, and then use it to locally invoke Lambda. As I mentioned, all Lambdas are triggered by events. So first of all, let's generate some event for that. So for here, the source service which is going to generate the event is API gateway. So when you give this command, it is going to give you all of the services that can trigger an event. So we will choose API gateway from here and then give that as a parameter to see the options. Here there are like 4 options. It can, so because Lambda API gateway can be used to integrate with the Lambda as a Lambda authorizer, which is the first one, and Lambda proxy integration or HTTP API proxy integration and so on. So the way we have defined here in the template above is a normal HTTP API proxy. But I want to show you how a REST API works. So for which we need the AWS proxy. Usually, how an API gateway event will look like is something like this. So it will have the actual body, which will have the message from the front end, and then the resource parameter, headers, and so on. But when you use it as a AWS proxy integration, when it goes through to Lambda, it is going to just send it as a proxy and just send this information. That is the top body information is what will get to the Lambda. So instead of using this full event for the testing purpose, as if we are using a AWS proxy integration, we will use this type of an event. So if you see this another file, sessions event, so this is what is here. So if you go back to our demo and remember my demo, we initially created a summary of the session. So the input from the front end was the session name and the event type, which is generate summary. So the event type is summary. So this what is going to go to the Lambda function. So now if we do a SAM local invoke -e. So if you give -e, that means you're going to give the event as the input. So I'm going to give the session event as the input to see how the Lambda function gets invoked. Now it is invoked. And yeah, one thing to highlight here is when you are invoking this function, do you see this one? Local image, and then it is getting a public image from easier. So what is happening here is SAM in the CLI, it is pulling a Lambda image and spinning up a local container. Remember I mentioned the Docker prerequisite. This is why we need the Docker here, so that it will create a local Lambda image and run your code in that and provide you the answer. So you've got the response here now as response code 200, and what is being returned is the actual event that you will be passing on to the event bridge. So it is publishing an event in the event bridge, but I put that in the response object just to see what is being fed. So now we have successfully tested the Lambda, but we have tested it through the existing small configuration of a normal API. Now, as I mentioned, let's see how it can be changed into a REST API with even more complex parameters. So if I show you in an console, an example API, let's take this one. So this is a REST API, which has a post integration to a Lambda function. And you have various other parameters configured as part of this API configuration, such as from the Lambda response, what is the response code that is being returned, and what are the response headers being returned and allowed, and the response body type, etc. So if you want a proper configuration, everything done through SAM and without touching the console, then you need to code each of those parameters. So an easier way of how it can be achieved is, one way is if you have an example API in the console, you can go to the deployed stage and go to the stage actions and do an export and export it in an OpenAPI format. And since we are going to use it in SAM, choose the YAML format and also export with the API gateway extensions so that you get the full information from the AWS API gateway and then export this API. So when you export it, you will have something like this one. So I've exported it and put it into a .yaml file in our project root folder. Yeah, it's here. So this will look like something like this. So you are going to have the regular OpenAPI format if you're familiar with OpenAPI format. So even if you are exporting an external API from some other system and want to put it as an AWS API gateway, this is an easier way of doing it. You just get the OpenAPI specification and use it in your SAM template. So what you're doing, so this is an external file. So we have our template file separately and we are having the API.yaml file. So you can use all the information here as this. So if you see, this is the one I can mention. All the API gateway configurations like the header methods allowed, response codes, everything gets copied into this as is. And the main thing that you need to change here or customize for the new deployment is this credentials. So this credentials is the role that API gateway will use to access the integration point. So in this case, the integration service is Lambda. So do not hard code it like the way I have done here. Use an parameterized attribute, which because your role itself, you might be creating in your SAM template as part of the same template or you're fetching from another template. So use the parameterized attribute rather than hard coding. So credentials is one that you need to customize. And the next one is the URI. URI is the actual endpoint which you will call from API gateway. So here the endpoint is Lambda. So it is the syntax is in a particular way. So have a look at it in the documentation and then you have to have the actual Lambda name here. Again, do not hard code it, but get the actual name of the Lambda from your template and parameterize it and put it here. So once you have done this, now you have to use this API YAML in your actual template YAML. So let's see how we do that. So if I go here, just a minute. So what we are going to do here is we have to introduce another resource. So far we didn't have a separate resource type for so now as a REST API, we are going to add this. So if I've given a name, REST API, and the type is this one. So this is the serverless construct used for REST API. And I'm giving a stage name. And in the definition URI, I'm giving the path to the API.yaml file. So we need not define anything else in the template. We are just using the OpenAPI YAML as is here. And in your Lambda function, also you need to make the changes so that you will refer this API resource in here. That I'm going to change this part. So what I have done is, so I've given API event type and as the REST API. So I've done a reference of this API in here and I've given a path and the method is going to be post. That's all we need to define here. And I'm going to add a few more things, but not go into the details of it. Those are the information of the IAM row and IAM policy that is required by the API gateway and the Lambda. I'm just putting it here, but not going into the details of it. Because this Lambda as further needs permission to write it to the event bridge. If you remember, we have examples of the events.put event permission we are giving to the Lambda. So all that I am adding it here. And then I've saved this. And just to show you that it is how it is working, I'm going to do a local build and deployment. So I'd say what happens in the build and deploy in the coming slides. So if we do a SAM build now, SAM will package all of your code and dependencies that you had inside this hello world folder and it will create a package. So now it will, just to check if your package has created a template correctly, you can do a SAM validate. So this will not do a deployment. This will just check if the template is right. So here actually we are getting an error. Let's see what the error is. So API proxy function, okay. So changed everything, but we had this name as still as hello world function. But everywhere I think the roles that I have defined is using it as API proxy function. So I'm going to change this function name as API proxy function and do a build again and do a SAM validate again. Now the template is valid. Now we will do a deploy to see if everything is getting deployed correctly. So use this, when you're doing it for the first time, use the guided deployment so that you will see all the steps. Stack name, you can give a name, or if you leave it blank, it will just take the defaults. Confirm changes, I give as, and role creation, give it as yes, because I want SAM to allow to create a role in order to do this deployment. For rest of the things, so this one give yes, because we haven't defined any authentication for the API gateway. All this was default. So now it is waiting for the change set to be created. So it will define all of the, so if I show you here, so this template is going to define so many resources. That is a policy. And so here you can see the resource type. IAM policy, Lambda permission, policy, actual function, and a API gateway deployment and everything. So now the create is in progress. And now if we go to the cloud formation, so if this is your stack that is in progress. So you can see the various events happening. And once that is complete, you will see it is create complete. So all of the resources are now deployed. And then just to test your API, you take let's find out where that new API is. Actually, when I did the recording, today is, you can see the date on my computer. It is 28th February. So this is the latest one that has been created. So I go into this. It has created a dev stage. So if I go into this, so this is the invoke URL that you have to use to call this API. So let's try post to this error, and we pass the data as the events file that we were using so far in our testing. So you can see that it is deployed correctly and you are getting the response from the Lambda function. All right, now we have seen how build works. So build, what it does is quickly at each of your resource, mainly the Lambda function, it will package your dependencies and code, and even there is a concept of Lambda layers. So we are, in interest of time, not going into that, but if you have like different layers, you have to finally create a package of it. And that's what is going to help you with. And after that, we are going to see about SAM sync. So SAM sync is something where you have your deployment, initial deployment, and then you sync just your code, a piece of it, into your resources without doing an actual deployment. So this is fine for a development environment, but do not do it in production. Use proper pipelines and deployment methods when you're doing it in production. But when you are testing, but you want to keep changing the code and pushing it into a test or a development environment, then SAM sync can be useful. So now, actually to see how SAM sync works and where it is really useful, I want to now shift the focus to the second team, which is the business application team, where we see from the front end, we just checked on how the Lambda function emits the events into the event bridge. So from the event bridge, there are various rules I mentioned, and the summary event, which we have been discussing so far, it actually goes into a step function. So step function, as it has like various tasks and it has a workflow needs to be defined. So how can we like easily do the step functions deployment? And SAM sync actually can be very useful in that. As I mentioned, it creates a temporary layer and it syncs your code into your Lambda function, which without an actual deployment or a stack implementation going on. How we can make use of that, mainly in step functions and also in the OpenAPI specification that we just saw. So let's say you have a initial step function or a API gateway deployment and we will just talk about step functions now. So let's say you have like just one state in your workflow and you have deployed it, and then you create the further steps and then you want to push it and see how it updates in your console. If that's the aim, then SAM sync can be very useful. Okay, looking into the step functions now. So far we have been talking about how local development helps you a lot. But step function is that one service which is easier to get started with on the build within the console, because it has got a very nice visual experience where you can drag and drop services into your workflow and configure your parameters. So this is our step function in the demo that we are using. So if you see, it is getting the session abstract using the title from a DynamoDB table, and it is invoking Bedrock and passing output of the Bedrock model into again an event bridge. And then we have the same thing for the thanks node generation. And then there is a process like it can wait for the user input and repeat the same thing. That's why you see the looping process in here. So once you do this visually and get this workflow created, then it is easier to take that code into your SAM template rather than building everything from the scratch. So this is the design of the Visual Studio. So there's a code part here. So this is called something called the Amazon State Language, or the ASL. This is again YAML, JSON if you notice. So you can copy this whole thing and put it into a file. So when I put it into a file, it looks something like this. So I have it in my project folder. So if you notice, I am now coming to a different folder, which is a TB project space. And I'm just having a separate template YAML file as well. So this is the full ASL of the step function. So, but let's start with a smaller one, just one pass task. This is just to see how it is getting deployed. So this is our ASL.json file, and this is the template file. So in the template file, I have defined the resource. So this is the construct for defining the step function or the state machine. And similar to the API gateway definition URI, you will have a definition URI where you will give the location of your ASL file. And then you are giving the role of the step function and the policy. So the policy, as you had seen, it needs policy or permission to call Bedrock models, DynamoDB table, and all that is defined here. So I'm going to try to build this template and then deploy this. So the build is complete. Now I'm going to deploy this. So again, it will create a CloudFormation tag and it will get deployed in your account. So I have run this previously. So it is saying it is going to modify the state machine as per my, AWS, as per the changes that I've done. So now, right now, this is just one step that we are going to deploy and it is getting successfully deployed. So now if I go to the state machine, I exit this one. Let's see. Yeah, I think this is the one. If I edit, should have only one state. And this file has got the full step function with all the states. So I will put the name of this JSON in here. Oh, let's do the other way around. We copy this one and put it here. And do a servicing. So what has happened is it has completed a build on its own and it has synced to the code. So if I go to the step functions now, do an edit. Now we should see the full step functions from that one state updated immediately. So in this way, you can, once you have the full workflow from the studio, then you can sync up the code and get it deployed in a very easy way. And now to show you how the step function is actually invoked, let's do a SAM local invoke. Now I'm back to the Team A app one, and we are doing that API invocation with the Lambda, which publishes the event in the event bridge. So back to that. So if we do that again once more, it is giving an output. So what it is actually doing is publishing an event into the event bridge. So if I go into the event bridge, so if you see this is the event bridge rules, and this is the event bus. So we have various rules set up, and the rule which matches this event is the summary input. So event pattern is something like this, where the event type is summary. So in here, the target is a step function state machine. So if I open this state machine now, you can see that has been invoked by the event bridge, and you have this one execution in running status. So if I open that, whatever in green is what is the completed states. So it gets the input from event bridge and it fetches the abstract from the DynamoDB table using the session title. So you can see the input and output in here. So the input is the actual JSON, which is having the data, summary, and your session title. So then it creates a prompt in the next step to be passed to the Bedrock model. So it is passed to the Bedrock Anthropic Claude 3 model. So the prompt is this: write a short and concise summary of the session title. So, and you get a model response as the session focuses on optimizes the, and this is what is displayed as the final summary in the front end screen. So the execution is in pause now, as you can see, because it's waiting for user input. Remember the demo, we did this one summary, and then we had a second step for creating a thank you note. So you are giving some feedback. So the step function is designed in such a way that it waits and resumes when the next set of input comes in. So I'm not going to the detail of those design, but it's a very interesting one to look at. So we have seen about SAM sync and also about SAM deploy and the differences between them. So far, we have seen about the local environments and how it can help developers and testers to progress the serverless application with speed. So though you can use SAM deploy to put your resources in any environment, there needs to be some governance and control over who deploys what and where. So when you have various teams doing various parts of the application, you need to have an oversight on how this can be managed. So that's where the proper continuous integration and continuous deployment, the CI/CD methods, comes in hand. And also, so we were talking about like various teams maintaining their own templates, right? So one good framework or model could be having a nested stack. That is, each team has their own template and deploys them in their own local environments or within the AWS accounts. And then when it comes to higher environment like integration testing, there may be a central team who takes control, merges these templates into a main template, and then deploys it into an environment. So how do we do those kind of deployment in a very streamlined way is where we use SAM pipeline. So SAM pipeline is the way to, as an abstraction over your process. So it has the ability to integrate with the CI/CD systems like AWS Code Pipeline and also third-party systems like GitHub, GitLab, Jenkins, and Bitbucket. So let's take GitHub as an example, which is what we will see in the demonstration as well. So if the developers are pushing their code into a GitHub repo, how do you set a workflow from the GitHub repo to be deployed, the resources to be deployed into your AWS account? So there can be a staging account, there can be a different production account. You can set up your pipeline in such a way that it first goes into a staging account. And maybe you set up a flag for a manual approval, and then it goes into production. Or you can have a fully automated pipeline as well. So this is a normal CI/CD process, but how the SAM makes it easier is using this bootstrap step, first of all. So when you use a bootstrap, for whichever CI/CD process that you use, what you need is the necessary permission and rules for allowing the tool to go and do the deployment in your AWS accounts. SAM pipeline bootstrap will take that role and create necessary resources, which is the buckets into which the code has to go into, and the necessary CloudFormation and pipeline execution roles in each of your deployment accounts will be automatically created by the SAM pipeline bootstrap. And after that, it will also create the workflow file, which has all the information to pull the changes from your repo, like GitHub or GitLab, and pushes that changes into the staging and production, or how many other stages that you have deployed in your pipeline. So this is the concept. We will see a quick demonstration of this before closing the session for let's do a SAM pipeline in it with the bootstrap command so that we can set up the pipeline in an interactive way. So we choose a pipeline template. So I mentioned there are 5 different CI/CD systems supported. So we are going to choose GitHub Actions as an example. Do you want to set up now? If you choose no, you can still reference other business, and we will set it up. So give the stage name. So you're giving it as a dev, and then we are using your role, which can be used to go and deploy the resources in the AWS accounts. So I'm using this true default option because I have a profile in this IDE, which has the ability to connect with the account. And I'm going to deploy both stages, like development and production, in the same account. But when you're setting this up, if you keep 2 different roles, then or 2 different profiles, that will be used by the pipeline to go and assume that role and deploy the resources in each of the account. And enter the region, and default is IAM, and all of this IAM user where you need not create. This will be automatically created by the pipeline. So pipeline execution role, CloudFormation execution role, and the bucket artifact. And this one you have to give n because we are not doing an image type plan function. And it will ask for to summarize whether you are okay with creating all this. Yes. So after it has set up the development stage, it is going to ask the same set of parameters for the next stage. So you can do more stages if you want. In this one, we are showing 2 stages, development and prod. And if you see, it has created the access key and secret access key. This is an important parameter which has to be set up in your GitHub repository for this workflow to work. So say you have to save this in a safe place. And now we go and do the second stage. So for this name, we give as prod and choose the role, all the default role creations, no for image type, and confirm the above values. Should we proceed with creation? Yes. Again, this will take some time. So while it is progressing, let's go to the GitHub repo. I have created a repo called Conf42 Cloud. And here, go to the settings and secrets and variables in actions. Create a new repository secret. For this, you will create the access key ID, and the same way do it for the secret key and the value. So it's now added. I'll go back to the action is name, complete file. So give a stack name. So we are giving team A dev pipeline. So that will be the stack name for the development pipeline. And for the production, we will give it as team A thread pipeline. So we have created a .github workflow now. So if you go here, so there is a workflow and a pipeline created here. So I have done an initial push from the IDE to this GitHub repo, so the team A app one, so you can find all of the resources from the app one folder in here. Now, if I go into the IDE and make some changes here, push, let's say, and then add that change and do a commit and do a push. So now, not just the changes would have pushed in here, but if we go to actions, you would see a pipeline in here getting started. So it is in the test start, then it will go into build and package, it will deploy and an integration test, and then go into deploy and prod. So this step, deploy testing, when it is completed, you will see one stack getting created in the CloudFormation. So something like this, one, and like this, Team A development pipeline and Team A production pipeline. So after each of this is completed, you will get the stacks deployed into that. And this one, where you see the build and deploy feature, is when you submit any changes into a feature branch. So that will get deployed as a separate pipeline. And when you merge and do a pull request from the feature branch into your main branch, then it will get sucked into your actual testing environment and production environment. So this is now the build is complete. Then the deploy is for the testing has started. So you should be ideally seeing a stack in here. So while that is happening, let's go back and do a feature branch commit. Let me check out into a branch called feature 1. And I will do another change, testing feature branch. Yeah. And add this feature 1. Commit this. And you push this into the feature 1 branch. So when you do this one, so this pipeline is already deploying, but there should be another testing feature 1 branch that is created here, which will get deployed as a separate pipeline. So now if I go into the CloudFormation stack, so you can see that the Team A development pipeline, one is completed, development pipeline is completed, and the prod pipeline is in progress. So why you are seeing it as an update is, I was just testing out since yesterday on and on. So it is going and updating in the same stack. Otherwise you would have seen it as create in progress. Okay, so let's go back and see the testing feature branch. So I have this done in another repo. I will show you that in the interest of time. Let's not wait for the other one. So if you see when you are testing feature branch, it will go into this path and get deployed. And after that, when you do a pull request, it will then pull the changes from the feature branch into the main branch and get deployed. So we can do the pull request after the feature branch is completed. So as you see, the feature 1, it's now in update in progress. So it is like separate set of resources created for each of the pipeline. So that we do, since we are doing it in the same account, there will be duplicate. But when you do it in a practical example, you will be doing it with different roles and in different AWS accounts. And maybe with also checkpoints of not to just directly go into production. You might have some testing, just like automated testing or manual testing, followed by approval and then going into production. The usual CI/CD process. So now the feature 1 is completed. And now if I go here and do a pull request, create a new pull request. So I'm doing this feature 1. So this is a change that I have made. Create pull request, create pull request. Okay. And you are now merging. So now once you merge, automatically in the actions, you should be seeing another pipeline triggered where it is going to start the test and it is going to do this flow this time and put it in production. I'm not going to wait for this to complete, but hope you get the idea of how these pipelines can be combined with some SAM pipeline. And hope this has been useful to you in seeing how you maintain your SAM environment and templates for different teams independently, and use SAM to not only deploy infrastructure code, but use it as a CLI as well for your local building, testing, and testing your deployments. And then finally, if you're in a DevOps role, use pipelines to deploy them together. So this really speeds up the way that you build a serverless application. And as you can see, the serverless landscape is huge. So there are so many other services in the AWS landscape that you can use. And you can bring everything under the SAM template and speed up your deployment. And when you are bringing it in the pipeline, you're just bringing everything into the deployment phase very easily. And also, if you see this architecture, why it's chosen is to demonstrate the fully event-driven mechanism. And in this part, we didn't see, that is the image generation. So that is maybe an extra feature set that your application can have and deploy. I want to end with giving you some useful resources. So this serverless LAN patterns contains a lot of starter packs. There's your SAM template with different runtimes in Python, TypeScript, Java, etc. You can just clone those GitHub repos and have serverless. Like if you want to have event bridge triggering step functions, there is a pattern for that which you can use. The next one is it's a YouTube series from one of our senior developer advocate. His name is Johnson. So this is a series of YouTube videos, each one going in depth and going into a hands-on session to explain about each of the SAM feature. So if you want to really get started with SAM and know about each of its features in detail, this is a very good YouTube series. Thank you so much for listening to me today. Connect with me on LinkedIn and keep watching the space on my LinkedIn feed. I'm planning to put the app code and the SAM code into a GitHub repo so that you can have a try of your own. Thank you.